You know, when you picture a graveyard on a damp, foggy morning.
Yeah, like total Gothic vibes.
Right, exactly. You expect to see rain dripping off the headstones. It's an inherently moody image. But imagine looking down and seeing the ground itself weeping, like actual black tears welling up from the soil. So welcome to today's deep dive. We are pulling from a bunch of mycology journals, chemical databases, and oncology reports to bring you on a journey into the world of Lacrymaria lacrymabunda.
Which is commonly known as the weeping widow mushroom.
The weeping widow, yeah.
Yeah.
Our mission today is to explore how this ultimate goth mushroom isn't just, a Halloween prop.
I mean, it literally grows in graveyards.
It does, but it also happens to be the center of this unresolved psychedelic mystery, and amazingly, it carries a cutting-edge cancer-hunting protein.
So to really understand the weeping widow, you have to start with that striking visual.
Yeah.
It has this densely hairy tawny brown cap with a fringed cottony margin.
Kind of like a ragged mourning veil.
Yeah, exactly like a veil. And it loves disturbed urban soils. So we're talking garden edges, mulch, and of course graveyards. But the main event here is a phenomenon called guttation.
The weeping part.
Right. During moist weather, the mushroom exudes these clear droplets of water right along his gills. And the weeping widow produces heavily ornamented, warty spores that are jet black.
Oh, so when those mature spores drop,
They get caught in the moisture, and that turns those clear droplets into dark, inky tears.
it's literally like the mushroom is sweating black ink. But, why? Why would a fungus expend precious metabolic energy just to cry like that?
Honestly, the biological purpose behind the guttation is a massive mystery. Scientists aren't totally sure.
Wait, really?
Yeah, some theorize it acts as a lure to attract insects that will then carry its stores away. Others think it functions as like a pressure relief valve for rapid growth, or even a mechanism to flush out toxic metabolic waste.
Okay, so the tears are a mystery, but that is totally overshadowed by a chemical mystery hiding in its flesh. Because if you look at the prominent coconut natural products database, it lists the weeping widow as containing psilocin.
Right, which is the active metabolite that makes magic mushrooms psychedelic. It's a detail that has tantalized mycologists for years.
Okay, but I have to eagerly push back on this, because that just doesn't track for me based on the sources.
Oh.
Yeah, if it's packed with psilocin, shouldn't it bruise glue when you pick it? I mean, that bluing reaction is the classic hallmark of psychedelic mushrooms. But all the field guides say the weeping widow just degrades into a dark, soggy mess when you handle it.
No, you're totally right to push back. That contradiction is a massive unresolved paradox in modern mycology right now.
So the database might just be wrong.
Well, no primary analytical study has ever actually confirmed the presence of psilocin in authenticated specimens of this mushroom. Yeah, so it could be a database error that just got blindly repeated. Or, the compounds might be sequestered in a way that prevents the bluing reaction entirely. It's really this high-stakes question waiting for someone with modern mass spectrometry equipment to definitively solve.
Okay, so its psychedelic properties remain a bit of a ghost hunt right now, but its actual chemical superpower is verified in the lab.
The PVL lectin.
Right, deep inside this fungus is a protein called the Psathyrella velutina lectin, or PVL. And from reading the oncology reports, I picture PVL like a highly trained microscopic bloodhound, or molecular Velcro.
Molecular Velcro is a perfect analogy because that Velcro is physically shaped to hook perfectly onto very specific targets called agalactoglycans.
Which are what, exactly?
To put it simply, they're truncated carbohydrates. So basically, broken sugar chains found on the surface of certain cells, and PVL has what chemists call a micromolar affinity for them.
Meaning it acts as a perfect lock-and-key fit for those specific broken sugars. And those broken sugar chains happen to be overexpressed on the surface of lung, breast, and colon carcinoma cells, which is wild.
It really is.
Yeah.
So this protein acts like a perfect highlighter pen that only colors in the tumors.
Oh, wow.
Yeah. It physically binds to the deformed surface of a cancer cell while just sliding right past the smooth, healthy cells, which allows oncologists to delineate cancerous tissue with incredible precision.
It's just a beautiful irony. You have this bitter, inedible graveyard fungus weeping black tears in the dirt that somehow provides an incredibly precise, life-saving tool for modern medicine.
Yeah, it completely flips our expectation of where our most advanced medical tools actually come from.
Which brings us to a crucial thought to leave you with today.
Ah,
If a common, overlooked mushroom growing in urban mulch can hold the key to targeting cancer cells.
what else is out there?
Right. It makes you wonder, are we destroying our greatest future medicines by paving over these seemingly ugly or disturbed urban ecosystems before we even test them? Maybe the next time you walk past a damp, dark graveyard, you won't just see decay, you'll see discovery.